So for, let's see, 6.3, numbers 7, 8, and number 9, I want to give some comments. If you're looking at this homework after you see this video, you'll see that number 9 doesn't exist anymore. It's because it's a problem that wasn't the problem that I thought that it was when I assigned it, and I apologize for that. But let's just talk about 6.3, number 7. So for this problem, we're given a function where y is the independent variable and x is the dependent variable, and bounds on y, and we want to rotate this about the line y equals 4. You don't need me to talk about this problem in a lot of detail. Let's draw a picture. I think that's the first step for all of these problems, typically. So here's my y equals 4. What does this function look like? There's a couple of ways that you can go about doing this. Because it's a function where my independent and dependent variables are switched, if I plug it into my calculator, it's going to give me my values in reverse, meaning that it's going to be graphed as a function of x. But one thing that you can do is even just to plot points. And in this case, we see that because y is our input value, if I plug in a value of 0, I get sine of 0, which is 0, and I end up down here at 0. If I get a y value of pi over 2, I plug that in. Sine of pi over 2 is 1, so this gets an output of 3. And then as I have a y value of pi again, this will go back down to 0 again. So maybe this doesn't give everybody enough information to have a great idea of what it looks like, but I know that it's a function that it's going to be a periodic function, and it's maybe going to be a little squished, but sort of a squished sine curve that we've flipped about the y equals x axis. So let's draw what this happens when we rotate this around the line y equals 4. 4 is a value that's a little higher than pi. Maybe I need another color. But if I flip this up here, then each one of my shells in this case, if I wanted to visualize sort of what's going on, this is my rotation, so it makes this donut looking thing, and I'm going to color one of my shells in green here to give me a sense of what's going on. So what is this green shell? What's going on? The first thing that I want to notice is the fact that the width of this shell is in terms of y, so that I know that I'll do all of this in green. My width is a dy width, and that gives me part of the way to my formula of what I want this to be. Again, because we're talking about shells, I know that the total volume of this shell is going to be 2 pi r h times the width of each shell, which in this case is dy. One of the things that I can know right away is what the bounds are, because they're given in the problem. The bounds are going to go from down here at 0 up until pi. And there's a tendency, some people want, because this is the face of the region that's being rotated around this axis, right? And one of the problems that people sometimes do is that they want their bounds to go extend all the way through the entire figure, but that would actually be too much, because this one face makes a complete revolution in a circle, so I just need to measure, like, what is the distance along this one face, and if I went all the way up here, that would be way too big, because that's being rotated all the way around. Anyway, so now we only have 2 more pieces to figure out. I need to figure out what is my r, that's the radius, and what is my h. So my radius in this case, the center of this cylinder shell is going to be at y equals 4. And so if we went all the way down to the x-axis, my radius would be 4. But I'm going to limit myself. I'm going to not always go down all the way to the axis. As my y value changes, the radius is going to shrink. And that means that in this case, my y value is going to be the entire radius of 4 minus my y value. So I just said that r in this case is equal to 4 minus y. And what is h in this case? H goes from 0 out until I hit this curve. And thankfully, this is already solved with y as my input variable, so that's just 3 times the square root of the sine of y. So now that's all the information that we have. Let's summarize that nicely on another sheet of paper. That means for 6.3, number 7, we just decided that we're going to integrate from 0 to pi of 2 pi times r, which is 4 minus y, times h, which is 3 times the square root of the sine of y dy. And that's all that they're asking for in the first part, that we aren't asked to integrate it. But for the second part, this is something that you can do on a calculator. Oh, look. How do we integrate this? We have to input it, and recall that, at least for this type of calculator, we're going to enter our function. So f of y is what our function name is, but really this could have any variable name. And in our calculator, I'm going to call it f of x. And then I'm going to integrate with respect to x. And the bounds are going to go from 0 to pi. So I'm going to type that into the calculator. Maybe you don't need to, you don't need me to watch. I'm going to go into my math menu and find integral, and I'm going to integrate this function, which is 2 times pi times 4 minus y, and notice I'm using the variable x instead of y, times 3 times, this is something that people sometimes get tripped up on. How do I do a square root in a calculator? Really, it's just raising to the 1/2 power. So that's the way that I do it in my calculator, to the 0.5 power. And let's see, I ended that parentheses, I ended that parentheses, and that's all my parentheses. And now I need to tell the calculator that I want to integrate with respect to my x variable, because I rewrote it in terms of x, going from 0 to pi. And that'll think a while, and it'll figure it out, and I'll get back to it at the end of the video. So that's 6.3, number 7. Let's talk about 6.3, number 8. So this is one in which we're given this integral, and we aren't asked to compute it. We're asked to talk about what does it look like in terms of the pictures. We know that we're dealing with shells. If I weren't told that, then I think it would be really hard. And we're also given some clues. I'm going to start by drawing a picture. So because we're integrating with respect to y, I know that these are the variables as y goes from 0 to y equals square root 3 on the y-axis. That's the first piece of information that I want to have. And I know that these other two things are going to be one of r or h, because typically when we talk about this, this is going to be the integral of 2 pi r h, and in this case dy. So let's just pick. I mean, it's sort of arbitrary. One of these chunks is going to be r, and one of these chunks is going to be h, and let's see what happens if I just set it up and look at it. So let's suppose that r equals 4 minus y. What does that mean in terms of our picture? That means that whatever our y value is, maybe I'll say, and that would mean that h would be equal to 3 minus y squared. So let's draw a picture. What does 3 minus y squared look like? If that's my height, it means that if I give you a y value, it's telling me that the height is going to be exactly 3 minus y squared. So when y is equal to 0, my height would be 3. And when y is equal to square root 3, I have to plug in square root 3 for y and square it and get 3. So my height would be down here at 0. And really this is a sideways parabola. So if I'm thinking of my heights, I'll color this in blue. For a given y value, let's take out this chunk, dy. This height is given by this curve. And then the radius is going to be 4 minus y. Well, if the radius were just exactly equal to 4, this is actually really similar to the last picture that we had, then it would go all the way up here to 4, but it's not. It's 4 minus whatever our y value is. So that is, this formula follows exactly what we would want it to be for a cylinder in which the radius 4 minus y shrinks it up to be right at this width, and then the height would be given by this curve. So in this case, we have that the line of rotation is y equals 4. And the heights, in this case, of each of the shells is 3 minus y squared. If I had picked it in the opposite order, something crazy would have happened, that when I start thinking about what my radius is, and it's 3 minus y squared, that no longer really makes sense in geometric terms, because usually when we measure where our dy is at, it's not in terms of a y squared variable, it's in terms of a y variable. So that's why I knew that this would probably need to be what the radius is. And look, our calculator finished calculating for the previous problem. And the calculator tells me that this integral value is about equal to 109.724.